Understanding the Universe Through Scalable Navigation of a Galaxy of Annotations. This is the first in a series of videos that will help you understand what components make up AstroShelf and how to use them. AstroShelf is primarily a web application, and using the web application is the focus of this video. There is also an accompanying REST API called AstroService, which allows users to access the AstroShelf database programmatically. That API is the focus of the second video in this series. AstroShelf can be accessed by visiting astro.cs.pit.edu/astroshelfv3. If this is your first visit to the website, you can create an account with the .edu email address by clicking on the Create User tab, submitting your account details, and then confirming your account via email. If you already have an account or have just created and confirmed one, you can log in by clicking Enter Site on the bottom right. The AstroShelf interface is centered on navigation of the sky. What's displayed when you first land on the web application is a patchwork of SDSS images that we can navigate by clicking and dragging, or by zooming in and out. What makes AstroShelf useful and unique is that these images are connected to a database of celestial objects and annotations on those objects. If we right-click somewhere on the navigation, AstroShelf displays a menu after finding the nearby SDSS objects. From this menu, we can interact with the nearby objects in a number of ways, such as making an annotation, seeing detailed data about the object, and bookmarking the object for later navigation. We can also annotate or bookmark the coordinate that was clicked on, or the visible area on the screen. To demonstrate the more in-depth features of AstroShelf, we'll walk through an example of how an astronomer or student of astronomy might use AstroShelf to facilitate their studies. You'll probably learn more from this video if you follow along and perform the steps on your own AstroShelf account. Suppose we want to look at the spectra for quasars at a moderate distance from Earth and record some observations about those quasars. The AstroShelf web application has a built-in interface that will allow us to query the Sloan Digital Sky Survey, or SDSS, and interact with any celestial objects recorded in Data Release 7. To query SDSS for quasars using AstroShelf, we can begin by clicking on the Search Objects tab. Here, we're presented with an interface that will guide us through the construction of a SQL query to SDSS. Let's expand these sections to see how to build a query. The From section indicates which table of SDSS to query. By default, it queries the photo object table joined with the spectrum object table. We'll leave this default. Next, the Parameters section lets us pick which data fields we want back from our SDSS query. By default, we'll get the object IDs and their right ascension and declination. We could add more, but as we'll see later, we can get more information after submitting the query. For now, we'll click Add Parameters. In the Conditions section, we can apply filters to our query. To get quasars, we can select spec class as the parameter, equals as the operator, and 3 as the value, which corresponds to QSO. Then click the plus sign. To specify that the quasars be moderately far, we'll select redshift as the parameter, between as the operator, and 1/2 as the value, meaning a redshift between 1 and 2, and click the plus sign again. The Limitations section lets us restrict the quantity of objects we receive from the survey. We'll set the tops field to top 100. If this is not set, we may end up waiting for thousands of results. Finally, we can hit search, and the results will appear in the Results tab. Now we have a list of 100 moderate distance quasars. As requested, the results table lists the object ID, right ascension, and declination of all those quasars. The coordinates here act as links that will jump the navigation to the specified position. Crosshairs will appear that help identify which object is at the center of the screen. Zooming in can also help identify the object in question. The crosshairs can be dismissed by the crosshairs button at the top of the screen, which acts as a toggle. If we want more information about any object in particular, we can go into the Results tab and click the More link to view all of the parameters we left out of our initial SDSS query. Back at the Results tab, we can generate a trend image using the spectral data for all the objects returned from our query. However, this feature won't work right now because some of the objects may not have spectral data. If we open the Search Objects tab, and then within that visit our query history, our most recent query is listed at the top. To edit the query as text, we can click Copy, which copies the query into the Direct SQL tab. Note that it's also possible to edit the query as text from the Guided SQL tab we used earlier. To guarantee that the objects returned from our query do have spectral data, we need to change this left outer join to an inner join. An inner join only returns photo objects that match with a spectrum object, whereas an outer join would return any photo object. If we go back to the Guided SQL tab and reset the form, we can see that doing an inner join was an option in the From section. Now, we'll hit Search on the edited query in the Direct SQL tab. In the Results tab, now we can click on Trend Image to generate a trend image. There are a number of parameters to configure here, but a notable one is choosing Rest Wavelength or Observed Wavelength. We'll leave it as Observed for now and click Create. Each row in the graph is a spectrum image for an object in the results of our query. We can hover over any row to load the original chart from SDSS. To freeze the chart selection, we can click on a row. The chart also acts as a link to the full-size image. To unfreeze the selection, just check the Image Selection Frozen box. Different sort options are available for the spectra, including color. Just change the sort parameters and click Sort. You'll notice that the trend image was rearranged. The sort order can also be set to ascending or descending. AstroShelf has other features to give users a better visual understanding of their queries. One of these features is the ability to generate an overlay on the sky. We can go back to the Results tab and click Create Overlay below the query result. Here we can name the query, let's call it Quasars, set the fields to Object ID, and choose a high contrast color like cyan. Then, click Create to generate the overlay. If you don't see any change, it's because your objects aren't in the scope of the navigation. Let's go back to the Results tab and navigate to one of our objects. Now we can see it marked by the triangle. There is an Overlays tab from which we can change the opacity of our overlay. The first and LSST overlays can also be revealed from this panel. The other visual feature of AstroShelf is the ability to see results as thumbnails. Again, going back to the Results tab, we can see thumbnails by clicking the Thumbnails link below the query result. The Thumbnail tab appears with images of all the quasars in our query result. If you hover over the thumbnails, crosshairs are provided to help identify the central object. Clicking on a thumbnail jumps the navigation to that object's coordinates. The thumbnail can also be right-clicked to see the object's coordinates or to pull up the object's details. If an object is of particular interest, we can add an annotation to it by clicking Add Annotation in the Object Details tab. As mentioned earlier, it's also possible to add an annotation from the right-click menu on the sky navigation. In the annotation dialog, we can enter a title for our annotation, set privacy options, and enter the annotation contents. The privacy options are private, shared, and public. A private annotation is only accessible by the user that added the annotation. A shared annotation is available to all of the groups that a user belongs to. And finally, a public annotation is visible to all AstroShelf users. There are 3 available content types for an annotation: text, tag or keywords, and link or URL. No matter what's selected, the contents will be searchable once the annotation is submitted. Click OK to add the annotation after completing the form. If we wanted to annotate all of the quasars at once, we could go back to the Results tab and download a CSV or Excel file containing the results of our search by clicking one of the 2 buttons. After downloading the CSV file, we could write a program that reads in the contents of the file and submits annotations programmatically using the AstroService API described in the next video. Before annotating these objects, we might want to see what other annotations have already been applied to them in AstroShelf. To do so, we can open the Search Annotations tab. Here we also have the option of viewing our own annotations, as well as all annotations from groups that we're a member of. In the Search tab, we'll select the Redshift From parameter and set it to 1. Then hit the plus sign. Then we'll select the Redshift To parameter and set it to 2, and hit the plus sign again, and then hit Search. There are already 86 annotations on moderate distance celestial objects. We could refine the search further to only include annotations directly on objects, rather than annotations of annotations, by selecting a target type of object in our search. Now we've reduced our result set to 55 entries. We can get the full details of an annotation and its object target by clicking on More in the Results tab. If we want to save a result for later, we can click Add Bookmark in the Object Details pane. Bookmarks are private, so we can give it any name and click OK. After submitting, we can open the Bookmarks tab on the bottom left and open its Annotations tab. We'll see the bookmark we just created at the top. We can also delete old or unwanted bookmarks by clicking the X button. The Bookmarks tab also has Locations and Objects bookmarks. Locations are just right ascension and declination coordinates. We can bookmark the current navigation position by clicking the Bookmark button at the bottom of the screen. We can also right-click anywhere on the screen to bookmark that coordinate, as well as bookmark any of the objects in the vicinity of the click. Thanks for watching this video on AstroShelf. If you have any questions or comments, visit astro.cs.pit.edu/astroshelfv3 and click on Credits to find current contact information.